Welcome everyone to this presentation. I'm going to give you an introduction to the JSON functions in Postgres 9.5. The motivation for this talk is that the support for the JSON data format is becoming very important in Postgres. So we're going to give you here an overview of what JSON is, why it is important, and we're going to look into the data types, functions, and operators in Postgres. This slide summarizes what JSON is. JSON is an acronym that stands for JavaScript Object Notation. It is a lightweight data interchange format that is very popular nowadays. JSON is preferred as an alternative to XML, so it has a few outstanding features, such as being easy for humans to read and write, easy for machines to parse and generate, and it is based on a subset of JavaScript. And it is also programming language independent, so you can use it from Ruby or Python. If you program for the internet, you know that XML used to be the data exchange format, but it was very bulky, with lots of nested tags, which occupy a lot of space. So extracting information out of XML was not very easy. On the other hand, the JSON format is very compact and very easy to traverse. So no wonder why it is preferred by programmers in these days. The next couple of slides is going to show you the JSON language specification. This is taken from JSON.org. As you can see, it is very simple. The first line here says that a JSON object is a collection of attribute value pairs or key value pairs separated by commas and enclosed in braces. The attributes or keys and their values are separated by colons. The attributes are always strings. The next line says that you can also have arrays. And a JSON array is a comma-separated collection of values enclosed in square brackets. And the last group here says that the values can be strings, numbers, other JSON objects, arrays, or true, false, and null values. Now this slide tells us that strings are enclosed in double quotes. That's important. And you can use Unicode characters, and to use special characters you precede them with a backslash. Now this slide tells us about the specification for JSON numbers. A number is defined in the same way that you do in a programming language. So you can have any number of digits, optionally preceded by the negative sign and followed by a decimal point, which could be followed by more digits. You can also use exponential notation, and notice that JSON has no way to specify binary, octal, or hexadecimal numbers. Okay, this talk would be centered around two main examples. The examples were prepared using Postgres server version 9.4.5 and the pgadmin 3 front end to run the definitions and queries. And version 9.5 of Postgres has just come out a few days ago, so we verified that nothing has changed. We will start with a very simple example. It's built around a regular, flat, open dataset with information on the 8 planets of our solar system. Remember that Pluto is not considered a planet anymore. Since 1992, it has been considered a part of the Kuiper belt of dwarf planets. Okay, so the data about the planets in our solar system looks like this. The information for each planet is encoded as a JSON object. You can tell that because it is enclosed in between braces. And inside that you can see that there is a collection of key value pairs. And the keys are strings enclosed in double quotes. And the values are strings, numbers, and some Boolean values. This dataset is fairly regular. and it contains details about each planet, including a name, diameter, mass, orbital period, whether it has rings or not, the number of moons, the rotational period, its axis, which is the average distance to the Sun, and its tilt or inclination. And all of the information is relative to the Earth, so it has been normalized, for which we have chosen a value of 1. The Earth has 1 for everything, and the rest is based on that. So particularly for the Postgres database, we want to know how it implements the JSON and what kind of operators and functions are there. So Postgres implements 2 JSON data types, as you can see in this table. One is called just JSON, and the other one is called JSONB. They are basically identical, and the main difference is that the JSON data type stores an exact copy of the input, and it gets parsed each time it gets accessed. And the JSONB type is a decomposed binary format, slightly slower to input, but significantly faster to process, since no parsing is needed after storage. And JSONB does not preserve the order of the key value pairs, and it does not keep any duplicates. For the planets example, we will use the JSON data type. Here in line 8, as you can see, the details are declared as JSON. And the next slide shows how we store the information in this JSON field. We just enclose the JSON object in single quotes because internally all of the key value pairs are using double quotes. And here we're using an insert statement to enter multiple records into the database. So now to check how the data was stored, we performed a query, and in the result set you can see that the carriage returns and spaces were preserved. And in line 8, the double colon followed by the keyword JSON is an explicit cast, but in this case it can be omitted. So now let's have a look at the JSON operators. We just start with a simple one. The most important, perhaps, a JSON operator is the dereferencing operator, because you use it to extract pieces of information. It is defined as the minus sign followed by the double greater than symbols, and we will call it the double right arrow or the double arrow operator for short. It returns a piece of data of type text. As you can see here in line 24, we use it to extract the planet's name. In line 25, we extract the planet's orbital period. If we want to perform a mathematical operation or a comparison of numbers, we need to cast this value, as you can see here on line 28. The double column notation is for casting, so we cast it to real, so we can retrieve the planets with orbits larger than the Earth's. Alternatively, we can achieve the same result by using the cast function, as you can see here in line 38. Okay, so that's basically the first example. Now let's look at something more elaborate. This is one of my paintings. This is the intersection of Namba Dotonbori and Shinsaibashi in Osaka in Japan. It is a popular destination for tourists and local people. And in this area you'll find lots of fashion shops, restaurants and electronic goods. So suppose you own a shop, not necessarily here, but you want to store customer contact information in JSON format. So the data looks like this. We will use 3 nested JSON objects, one for the name with family and given name, another one for the contact information, which includes home, mobile phone numbers, and email address. And another one for the address itself. Additionally, we include a summary of how much the customer spends in our shop. And we also have another field, which is an array of tags to search or classify the customers. Now we define the table customers, and this time we decide to use the JSONB data type, as you can see here in line 7. Suppose you're going to do frequent searches by postcode. In this case, in lines 12 to 13, we define an index on this field. And if you don't specify the type of index, by default, B3 index is used. In lines 17 to 18, we are a bit more explicit and we define a GIN index, which GIN stands for Generalized Inverted Index. And this is for the tags field. With that in place and the data loaded, we can now perform some searches. And the first search gets the whole thing to check how it has been stored. So you can verify that the JSONB data type removes the unnecessary spaces and carriage returns. And also notice that the order of the values is not preserved. It doesn't matter because it remains semantically equivalent to the original, right? Now, to extract pieces of information, we use a single arrow or a double arrow operators as before. Now, all of the operators we're discussing here can be used with both JSON and JSONB data types. And the single arrow returns a JSON object that is nested inside the JSON field. And the double arrow returns text. So, using a combination of these two operators, we can dereference or retrieve any piece of data stored inside the JSON object. This query gets the email and the suburb information filtered by postcode. Okay, this slide shows the difference of retrieving data as a JSON object or as a text. Sometimes you may want to retrieve a JSON object so that you can pass it on to an application for further processing. Other times, all you want to do is get a single piece of text or a number. There's another operator called the hash greater than or hash double greater than operators, and they offer an alternative way of retrieving data. To use them, you place the JSON object on the left and the path to the data on the right of the operator. And the path comes as a comma-separated list of words, enclosed in braces, and again enclosed in single quotes. This notation is meant to be a shortcut, but I personally prefer to use the arrow operators because I think they are more explicit. Always thinking of making the code a bit easier for others to read. Okay. Now, in case your data contains a JSON array, passing an index number to the arrow operator will retrieve the corresponding element. So like most programming languages, it is a zero-based array. And in this example, we retrieve the first element of the tags JSON array. So once you know how to retrieve the parts of a JSON object, the rest is handled in the same way that you normally do with SQL. In this example, we retrieve the suburb from the address and perform a count aggregation on it. And this is another aggregation, so we retrieve the amount spent by customers, grouped by postcode, and the retrieved field is converted to a real number. And after that, we perform aggregations using the sum, average, and max functions. And finally, we format the results using the toChar function, so the numbers are displayed nicely. The question mark is a new JSON operator to test for the existence of an item inside a JSON array. So if you see on this example, on line 115, we retrieve the records having the word techie in their tags array. There's also the existAny operator, which is given by the question mark followed by the vertical line. As you can see here on line 121, it tests whether any of the given items on the right are in the JSON array from the left. And the result is a boolean, a true or false value. And here we're checking for customer contact information that includes a fax or mobile numbers. Another operator is the existAll operator, with a question mark followed by an AND symbol. And so please refer here to line 131 on the slide, so you can see that it checks if all of the items in the list, which are given on the right, exist on the JSON field given on the left. In this case, we're checking if the customers have email and mobile contact information. Okay, in a similar way, we have the containment operator, which is given by the ampersand followed by the greater than symbol. So if you look here at line 148 in the slide, it checks the JSON field on the left to see if it contains the JSON attribute value pair given on the right. So here we check if the address contains the state NT as an attribute value pair or key value pair. And we have the reverse operator as well, which is a less than ampersand operator, which performs the same containment function but in reverse order. So if you look here, please refer to line 161 on this slide. The JSON field to check is on the right, and the testing value is on the left. So notice that I added an extra set of parentheses on both sides, on both operands, to make sure that the statement gets parsed correctly. Okay, so those were the JSON operators. Now let's have a look at how some of the JSON functions work. If I start with a simple select statement of ID and name for the customer table, I end up with a record set of 2 columns and a few records, as you can see here on the top left corner of this slide. Now, if I label that first query as T and invoke the row to JSON function, it converts each of those records into a JSON object. That's pretty neat, isn't it? Now, if I want to combine all of those records returned on the previous slide into a JSON array, all I have to do is to call first the array aggregate function and then the array to JSON function. You can see that the query is in line 13 here, and then the result. The whole thing comes in one line as a string. Now, if you want to pre-print the JSON object, all you have to do is to add a parameter to the array to JSON function. Just put the word true, as you can see here on line 21, and the result is what you see at the bottom of the slide. So we're starting to have fun with those JSON functions in Postgres. Now we want to go in the reverse direction. Suppose we start with a JSON array of JSON objects, and we want to convert this into a record set. So we call the JSONB to record set function, as shown here on lines 38 to 44. Notice that on line 44, we have to specify the shape of the record set that receives the data. And I think the best way to learn these functions is to play with them. So I encourage you to get your copy of Postgres and pgadmin and try all of this by yourself. Okay, let's go to the next slide. On this slide, we want to build a JSON object from key value pairs. And the function to call is called JSON object. Notice that there are several ways we can call this function. You can pass as an argument a list of pairs, like we do here on line 60, or alternatively, you can pass a flat list of even number of items, like we can see here on line 59, which I have intentionally commented out. And the result is the same. If you call it as in line 59, you have to be careful that you pass an even number of items. Otherwise, the function is going to complain because the keys and values have to be paired against each other. On the next slide, we see yet another way of calling the same JSON function. And this time we pass two parameters. The first parameter is a list of the keys, and the second parameter is the list of the values. And in this case, you need to make sure that both lists have the same number of elements. Otherwise, again, you'll get an error saying mismatched array dimensions. Okay, but wait, there's more here. I told you that these functions were going to be fun. So let's have a look at this one. Suppose you have a JSON array of items and you want to convert it into rows. So for this purpose, we have the JSON array elements text function. So you invoke it by passing the JSON array of elements, and it returns a record set with one column and several records. In this case, we're passing an array of the planet names. So now we went back to the table of planets from our first example, and suppose we want to retrieve all of the properties of one planet, but as a record set. So this is how we did it. There is a function called a JSON each text, and it takes a JSON field as a parameter. And notice that we call this function inside the from section of the select statement. And the result is a record set with the keys on one column and the values on another. Here I restricted the query to one planet, otherwise it would produce a lot of records. Actually, this function had me guessing for a little while. Let's see in the next slide. Initially I was calling it this way. I was putting the JSON each text function inside the select section of the statement. And notice that the result returns several records, but they are tuples. It was driving me crazy. I didn't know how to put them apart. So I think I found an article somewhere which showed me the way to do it. This article is actually listed at the end in the reference section. And I wanted to mention this to you to prevent you from falling into the same problem. Okay, let's go to the next slide. So remember we were using the referencing single and double arrows earlier? Well, there is a function that does the same job. So you can see it on this slide. It's called JSON extract path and JSON extract path text. Okay, so you pass to it two or more parameters. The first parameter is the JSON object to search into. And the next group of parameters are the path to the data. So as before, with the first function you get a JSON object, and with the second function you get the text. Okay, there's another one, a good one and easy one to use. It's called JSON object keys, and this function returns a record set listing the keys in your JSON object. And here we see another easy to use function. and very handy one is called JSON Array Elements. So this one returns all the elements of a JSON array as a record set. So we're getting close to the end now, and here we have reserved the most interesting functions to the end. So let's have a look at this one. This one is called JSON Populate Record. This function actually returns the key value pairs in your JSON object as columns in a record set. So to be able to do that, first of all we need to define a Postgres type, which is like a collection of type definitions for the resulting record set. It is like defining a table. So we do this in lines 121 to 128 of this slide, and then we call the function, the JSON Populate Record function. The first parameter is the type that we just created, which is going to receive the results. And the second parameter is the selection statement that retrieves the JSON object that we are interested in. And notice that this function produces only one record. So it expects the select statement to retrieve only one JSON object. And finally, the JSON Populate Record Set function. I found this function very interesting. It works in a similar way as in the previous slide. So it expects a type definition, and in this case the select statement can return several JSON objects. So it extracts the key value pairs and produces a nice record set of columns and rows and records. Alright, so we have covered most of the JSON functions and operators. I left out one or two functions which were very easy to understand. And let's have a look at some of the references. The first two links here will take you to the official Postgres documentation on data types and functions and operators. And the last two links are for those wanting to learn more, and it would take you to some articles written by other persons. They were done with earlier versions of Postgres, but they work exactly as described. And this one is a recent list of books that came out in 2015, in case you want to have any of them as paper-based references. So mind you that version 9.5 is the official version now, and it was just released recently, the beginning of January. And the online documentation is really good. So that's all we have for today. So thank you very much for your attention, and see you again next time.